Okay, I have started recording this. Once again, good morning, guys. Thank you so much for coming this today. And I'll be discussing, I'll be continuing our discussion on regression. Okay, kindly open the file that I sent. Can you see the file, guys? Can you see the screen? Can you see my screen, guys?
Yes, sir.
Okay, so this is the file that we were working on last time. So this is the data. Sabi natin na uh, oftentimes we have encountered data that's categorical, no? Um, Qualitative siya, no? And we can make use of this as part of our regression. However, we have to convert it into a dummy variable. Naalala nyo guys kung paano mag-convert ng dummy variable, no? Diniscuss natin yun. Kunyari, kung tatlong factors siya, ilang dummy variables ang ilalagay natin? Dalawa lang, no? It's always three. It's always a number of factors. When I say factors, yung unique elements ng variable na yun. Kunyari, in this case, sa race, there are two, white at saka non-white. So two factors to, then minus one, therefore, isang dummy variable lang i-introduce natin. For this, no, si gender dalawa lang din, si civil status dalawa. So we learned how to convert it in Excel to a dummy variable. Now, we started working on this last time. Ito na yung, ito. Okay. This is what we did. What I did was to complete this already, okay, and discuss it with you now para mas marami tayong ma-cover, no? So when we regressed this last time, okay, we used yung XReal stat add-ins natin. Okay? You can access that by Control M, no? And then this was our regression output where we included all our independent variables, education, experience, tenure. Take note na yung lilagay natin dito si non-white, female, si married, ito na yung mga dummy variables natin. We changed the name, no? Yung sa race, for example, yung non-white yung ginawa nating 1, so ang reference natin si white, kaya 0 siya. Of course, you can change this with another name. Linagay ko lang na non-white para alam natin na si non-white yung ano natin yung 1. Therefore, yung base factor natin o reference factor si white, no? Okay, so we generated this last time. Okay, sabi natin ito yung correlation. R squared tells us particularly adjusted R squared, ito yung ginagamit natin for multiple regression. Sabi natin ito yung variability ng dependent variable natin na si hourly wage that can be explained by our model. So ibig sabihin nun, 63% ang hindi kayang i-explain ng independent variable natin si education. Si education lang yung, sorry, hindi, multiple na pala tayo. No? Itong lahat ng variables na to. Okay? Adjusted R squared, 36.19%. Tapos itong mga information criteria natin, okay, si Akaike, this is your Akaike, no? Akaike, information criterion. Okay, this is your Akaike also corrected. And then your Schwarz Bayesian criterion. So we use this in order to compare our models. No? So the lower the AIC, the better kung nagko-compare na tayo ng dalawang models. And this, guys, as a way of review, Anova natin, analysis of variance. Okay, and ang ano natin dito, null hypothesis natin dito, B0 is equal to B1 is equal to B2 hanggang is equal to B7 is equal to 0. In other words, sinasabi natin dito na wala dito sa mga regressors natin ang significant para i-explain si hourly wage. And we learned how to compute this. The degree of freedom for your regression is the number of regressors, not counting yung intercept, no? So from education to number of dependents, pito yan, kaya pito to, no? So si residual, guys, yung degree of freedom na residual is n minus k minus 1. Okay, n minus k, k refers to your number of regressors, which is 7, okay, minus 1, so that gives us, kasi 526 lahat yung ano natin, di ba? Yung total observations, 526 minus 7 minus 1. Yung minus 1 doon, that's for the degree of freedom that's lost when you also compute for your intercept. Okay, residual, so that's n minus k minus 1, and this one is n minus 1. No? So 526 minus 1, that's 525. Okay, so we also learned how to compute for your SSR, sum of the squares of your regression, sum of the squares of your residuals, and sum of the squares of your total. If you recall, guys, si SS, sulat ko lang dito, ano, para very quick review. Okay, SST natin. Ano yung si SST? SST is the sum yan, that's the sum of what? Ano yung kino-compare natin pag SST? Yung mean, di ba? Yung mean ng, yung mean ng, dilitan ko lang, mean ng DV natin, which is hourly wage, diba? minus what? Minus yung hourly wage natin, no? Yung values ng hourly wage, right? Tapos ini-square natin yan, okay? So the difference between the average hourly wage and the hourly wage, the actual hourly wage, yung difference sila, ini-square natin, tapos sinasum up natin. That's your total, no? And then we have our SSR. Ano yung si SSR, guys? Sum of the squares of your regression. Okay, ito ngayon, guys, yung improvements ano natin sa model natin, no? So in-improve natin, gumawa tayo ng regression line. So ito na yung fitted natin, yung predicted value natin ng predicted value o yung forecast value, no? Minus so saan natin siya mina-minus? Kino-compare natin siya sa average, mean hourly wage, yung average yan. Tapos i-square natin yan, okay? And then saka isa-sum, no? And lastly, we have the SSE, which is the sum of the squares of your errors, or actually technically it's called residuals. And this is simply, ano to, yung sum ng, kinukuha natin yung difference ng, yung predicted value natin, predicted value minus the actual value. And then ini-square natin siya, okay, and then sinasum up natin. Okay, so ito yung SST, SSR, SSE. Now that's very important kasi the higher the SSR is, the better. Kasi ibig sabihin nun, yung regression natin is able to explain the variation, the total variation of your dependent variable. And alam natin, guys, yung R squared natin is simply your SSR over your SST. So that's 37, yan, 37%. Okay? So I hope this is clear to you guys. Importante na intindihan natin yung sum of the squares of the total, sum of the squares of your regression, sum of the squares of your errors or residuals. And then the mean square of your regression, MSR, okay? MSR is simply the quotient of your SSR divided by your degree of freedom. And then ito naman, MSE, also SSE divided by degree of freedom. Okay? Once we get this, guys, okay, by the way, ito, guys, yung MSE natin, pag in-square root mo yan, yun ang standard error. I think I showed this to you before. Square root nito, okay, that's now your standard error. And then your F-stat, simply your MSR over MSE. Divide natin itong dalawa, yun ang F-stat natin. Okay, please take note, guys, na alam nyo kasi sa exam, pwede ko kayong bigyan ng mga values dito tapos alamin nyo kung ano yung values ng nasa table na to. And then p-value, guys, you can get this by yung sa Excel, yung f.dist.rt natin. Our X is our F statistics. Our degree of freedom 1 is the degree of freedom of your regression, degree of freedom of your error terms. Okay, so that's how we got this p-value. Okay, and then we can make a conclusion. No? Conclusion natin, ang inference natin is that since the p-value is less than 0.05, sabi natin, when the p is low, the null must go. So we are rejecting the null hypothesis. Ano yung null hypothesis natin? That B0 is equal to B1 is equal to B2, lahat siya is equal to 0. So rinireject natin yon. Ang sinasabi natin, at least one of this, B0 hanggang B7, at least one of them is not equal to 0. Okay? So ibig sabihin, may pwede tayong magamit ng predictors para dun sa hourly wage natin. And ito na, guys, yung mga individual coefficients, no? Coefficients niya. And the thing to look at here is your p-value. Sabi natin, kapag less than 0.05 yan, then we cannot include that in our model. Ang null hypothesis dito, for example, for the intercept, beta 0 is equal to 0. Ito naman, B1 is equal to 0, B2 is equal to 0, B7 is equal to 0. Okay, so sulit ko lang dito para it's actually beta. No? Insert. Insert symbol. Okay, beta 0 is equal to 0. Okay? Tapos hanggang dulo yan. No? Ito. So this is wrong. This is beta 1 is equal to 0. Okay? Beta 2. Okay, etc. No? Beta 7 to 0. This is beta 6. 6 kasi siya yung pang-anim na variable, etc. No? Okay, I hope you got this, guys. Beta 2, beta 3 na to. Yung third regressor natin is equal to 0. So ang tinatest natin dito kung yung significance itong mga variables na to, no? Itong predictors natin. So this is beta 4 is equal to 0. And then beta 5 is equal to 0. Beta 6, yan, okay? So these are our null hypothesis, no? So, baka may nag-chat, may nag-question. Bakit kaya dyan? No? Name. Saan portion dyan? Which portion kaya yung nagsasabing error yung formula? Bakit? Hindi ito Ganito na lang dyan. I-post ko sa chat natin yung ano, no? Are you referring to the file? Kasi yung ano to, ito yung add-ins natin ng ano. Okay. Nasa canvas natin. Sige, pero dyan i-post ko dito yung file, Dali. How do I, wait. Tama ba dyan yung ano? Yung ang concern mo, yung file mismo? Nakuha niyo ba? Network disconnect. Diyan, nakuha mo yung file. Pause ko sandali Wala pa. Sa canvas mo binuksan. Pause ko lang recording All right. So again, by way of review guys, sabi natin na itong test for the significance of each individual variable, ito yung null hypothesis nun. And then we check either the t-stat or the p-value. Mas madali si p-value guys tingnan kasi titingnan lang natin dito kung sino dito yung greater than 0.05. Turns out that there are 4 variables here that are greater than 0.05. Okay, so itong mga hindi significant predictors. So technically, ang significant lang as far as this model is concerned, education, tenure, at saka female. Okay? So it's wrong also guys to immediately drop or remove all these 4 variables, no? Yung mga insignificant kasi sometimes it happens that correlated yung dalawang variable na yan. So pag tinanggal mo lang yung isa hindi magiging significant na, no? Okay, the last column here is your variance inflation factor. Ito sinasabi, yung variance inflation factor, it tells us about the multicollinearity, no? So ang base natin dito 5. If there's a VIF that's greater than 5, ibig sabihin nun may collinearity siya, no? With other independent variables. We don't want the independent variables to be collinear with the others. Okay? So ito okay tayo, wala tayong multicollinearity, no? Kasi less than 5 to mga to. If there's a great VIF, variance inflation factor, let me write that here. Variance inflation factor. No? Dapat less than 5 siya. No? Pag greater than 5, then may problema tayo sa multicollinearity. Ano yung multicollinearity? There's a high correlation between your independent variables. Gusto natin na yung dependent variable natin, si hourly wage, gusto natin highly correlated with the independent variables. But not the independent variables highly correlated among themselves. Bakit ganon guys? Kasi pag highly correlated sila, mag-aagawan sila sa pag-describe kay HR wage. So you'll have problems with that. No? So ngayon wala naman tayo nakikita multicollinearity, no? Okay. So sabi natin the way to go about this is to identify which among the four has the lowest absolute t-value. Turns out that si non-white yung pinakamaliit na absolute na t-value which is 0.25. Si experience 1.79, si married 1.56, number of dependents 1.34. So ang leaving variable natin, leaving means aalis, no? Aalisin natin. So we're going to remove this one at a time. Okay, hindi pwedeng sabay-sabay. So may aalis na variable and that is si non-white. Okay? Take note guys na ang tawag sa method na to is stepwise, no? Stepwise regression. In particular guys, yung method na ginagamit natin is called backward. Kasi may dalawang klaseng stepwise, may forward at saka may backward. Si backward guys, imo-model muna natin lahat ng mga independent variables natin tapos isa-isa natin tatanggalin, no? So pag natanggal na siya, syempre hindi na siya babalik. So dito ang candidate na living variable natin is non-white. So in this portion guys, tinanggal ko si non-white. Okay? If you take a look, tinanggal ko si race, no? Wala na si race dito, si non-white, wala na. So you're left with 6 variables. And then you run it again, no? Rinan ulit natin. Okay, rinan natin. Okay, so what do we have here? Ito na yung panibagong model natin. Let's call this model number 2. Yung kanina model number 1. Okay, so you have this one, the correlation, and then you have the R squared, adjusted, AIC, etc. Then yung degree of freedom na regression natin, kanina 6, di ba? Kanina 7, ngayon 6 na lang. 7 kanina, ngayon 6 na lang. Bakit? Nagtanggal tayo ng isang variable, no? Which is the non-white. So, overall goodness of fit, okay naman guys yung natin. Okay yung p-value natin. Ibig sabihin, we reject the null hypothesis that beta null is equal to beta 1 is equal to beta 2, etc. is equal to 0. Okay? So, rinireject natin na lahat ng mga regressors natin, yung natitira, equal to 0. And then we can find that here. Kita natin siya dito. Okay? Yung mga individual test natin ng mga variables natin. Okay, so again, look for the p-value that's greater than 0.05. Then we have lumalabas na si experience, si married at saka si number of dependents are insignificant. Tapos ang candidate natin for living variable is number of dependents. 1.33 yung t-stat niya as compared to 1.78 at saka 1.58. Okay. Now, before we remove this, yung number of dependents, kailangan guys, i-compare natin. Talagang, kasi ang lumalabas, i-compare natin si model number 1 at saka si model number 2 statistically. No? We have to compare them. Okay, just based on this, okay, si model number 2, ang tawag kay model number 2, yung tinanggalan natin ng non-white, it's called your restricted model. Bakit restricted siya? Kasi binawasan natin ng isang variable niyan. Kaya nga ang K natin dito, 6 na lang. Education, experience, senior, female, married, number of dependents. Okay? And then, sin model number 1, yung unrestricted natin, di ba 7? 7 yung natin dito, 7 yung regressors natin. Yan, 7. So, we have to statistically compare the two models. No? How do we do that? Okay, this is how you do it. First, in terms of R squared, sino mas maganda? Mas maganda si model number 2 kasi ang R squared niya, Okay, I just got this from this. Adjusted is 36.31%, while si model number 1 is 36.19. Also si Akaiki guys, mas maliit si model number 2. 1114. Again, saan ko nakuha yan? Dito. Okay, ito. So lahat ng mga to guys, makukuha natin sa ano yan, sa mga outputs natin. Hindi na natin kailangan we don't need to recompute them kasi nasa output na yan. And then also the standard error, 2.947, ito. And then si ano naman, 2.95. So konti lang naman difference, pero turns out that based on adjusted R-squared, Akaiki, and standard error, mas maganda si restricted, yung binawasan natin. Okay? But we don't stop there guys. Kailangan i-check natin kung statistically significant ba yung yung tinanggal natin na variable. Okay, so if you take a look at this guys, ano ba yung tinanggal natin na variable? Si B4, di ba? Sino si B4? Siya si non-white. Okay. Paano siya naging B4? Okay. Going back to the original guys, ito si non-white. B0, B1, B2, B3, B4. B3 pala, sorry. Kasi B0 to eh. B3, no? Yun yung B3 natin. Okay. Saan ako? Okay, anyway, sinabi ko naman dito yung non-white, no? So matatanggal si non-white. Okay, so we have to do an Anova test, no? Okay. Ang Anova test natin, we have to compute this, okay? So ito yung standard sum of the squares error ni restricted model 2 to. Itong full F is full or unrestricted. So ito si model 1 divided by degree of freedom for the restricted minus the degree of freedom for your full. And then we will have to divide that by the sum of the squares of your error terms for the full and then degree of freedom for the full or unrestricted. So ang ginawa natin dito guys, ang null hypothesis natin dito sa ANOVA natin na to is beta 4, yung non-white is equal to 0. In other words guys, gusto natin malaman kung talagang si beta 4, yung tinanggal natin dito, si non-white, di ba tinanggal natin dito siya? Nag-regression tayo, tinanggal natin si non-white. We would like to test kung significant ba si B4 kasi talagang significant ba siya? Or talagang equal to 0 lang ba siya? Kasi kung equal to 0 siya, then talagang tama na hindi natin tatanggalin. Tama si restricted model na tinanggal natin. Okay, again guys, si non-white as a variable, tinanggal natin siya, di ba? In modeling model number 2. That's why we only have 6. So ang tanong natin is beta 4, which is equal to non-white, is it significant? Is it equal to 0? Okay, so how do we do this? Okay, ito yung natin, ito yung pag-compute natin. So kailangan natin si sum of the squares of your residuals ni restricted. So guys, tinuro ko lang kung asan yan, kung saan kinuha yan. Andiyan na, lahat to guys nasa models na natin. Degree of freedom, okay, nasa table lang natin yan, ito. Okay, degree of freedom ni SSE. And then we do likewise for, bakit nandun na ako? We do the same for, okay, model number 2 to. This is model 2 and this is model 1. Apologies. Okay, si model 1 naman, SSE. Okay. Dito galing yon, no? dito kanina. Ito, no? Alright? So everything, guys, is already computed. We just have to get them. Okay? So what we do is we get the difference. Ito, guys. Kukunin natin yung SSE ni restricted which cannot be lower than SSE ni unrestricted. Okay? Which cannot be, sorry. Yung error, guys, ni restricted can be equal to unrestricted or can be higher than unrestricted. Bakit? Kasi tinanggalan natin, guys, ang variable, di ba? Tinanggalan natin ng regressor. Pag nagtatanggal tayo ng regressor, guys, ang nangyayari, possibly lalaki yung error term natin. Kasi sum of the squares of your error terms, kasi mas konti na lang yung variables na ginagamit natin. Remember, pag nagdadagdag tayo ng variables as a regressor, tumataas yung SSR natin. So pag tumaas yung SSR natin, liliit yung SSE natin. Alright, so this is their difference. And the difference of the degree of freedom is 1. Saan nanggaling to? Degree of freedom ni restricted minus degree of freedom ni unrestricted. Or, that's ilan yung regressors natin dito? 7. Ilan yung regressors natin dito? 6. So yung difference nila is 1. No? Okay. So let's compute for this. Ang numerator natin is simply, okay, just the ratio of this one. Just the ratio of this one. And then, ang denominator natin is, ito, guys, you remember what this is? SSE unrestricted over DF unrestricted. This is also your MSE, no? MSE, mean square error. Pag, di ba, dinivide natin yung SSE, no? So, lagay ko lang dito, this is the same as your MSE, mean square error, MSE, for your unrestricted. Okay, nasa table din to, no? 8.703. Tingnan natin yung MSE dito sa unrestricted. Ito siya, di ba? Ayan, no? 8.73. This is it. Which is just, di ba, SSE over DFE. Okay, so, okay, once we have this, guys, once we get the ratio, this is already your F-stat. That's your F-stat, yung quotient nito. Tapos kukunin natin yung p-value niya. So your p-value, you recall, this is your x. Your x is your F-stat. Then, what's this? Degree of freedom 1 is the degree of freedom nito, yung difference, which is 1. And then degree of freedom ng unrestricted, which is 518. Degree of freedom, DF1, DF2. So, undeleted din siya sa table na yan. So, you have a p-value that's 0.797. Okay? And this is our conclusion. Since the p-value is greater than 0.05, ito yung p-value natin. Okay? Ang conclusion natin, we fail to reject the null hypothesis that B4 is equal to 0. Tama nga, B4 is equal to 0. So ano ibig sabihin ng B4 is equal to 0? Hindi natin kailangan ipasok si B4 sa sa model natin. Okay? So in other words, guys, B4 or si non-white does not contribute to explaining our dependent variable, our wage. Which means that model number 2 is better than model number 1. Si restricted model natin, mas maganda kaysa model number 1, which is unrestricted. Bakit ganon guys? Remember si model number 2, tinanggal natin si beta 4 which is non-white. So tama lang pala na tanggalin yun kasi ang lumalabas statistically beta 4 is equal to 0. If beta 4 is equal to 0 si non-white, bakit pa natin siya ipapasok sa model kung wala nang pala siyang marginal contribution in explaining your hourly wage? Okay? So that's what happened here. So okay tayo. So we can now proceed na we go to the next model. So we have confirmed that model 2 is better than model 1. So ito yung gagamitin natin. Pero si model 2 guys, nag-regress tayo, lumalabas na hindi lahat significant. So anong gagawin natin dito? Tatanggalin ulit natin. So the cycle will, the process will continue. Parang nag-iterate lang siya. Tatanggalin natin si number of dependents kasi siya yung least significant among the insignificant variables by virtue of the lowest t-value. Okay, so tatanggalin natin si number of dependents. So dito, tinanggal ko na si number of dependents. Wala na siya dito. So anong nangyari dito guys, renegress ulit natin. Tapos 5 na lang yung ano natin, 5 na lang yung regressors natin. Then following the same process guys, i-compare natin si model 3 with model 2. Si model 3 guys yung restricted kasi 5 na lang yung ano natin, yung regressors. Si model 6 ngayon, siya yung magiging unrestricted. We're now comparing model 3 and model 2. No? It doesn't make sense guys to compare model 3 and model 1 kasi mas maganda si model 2 kaysa model number 1. No? So bakit natin i-compare si model number 3 kay model number 1? In terms of R squared guys, mas maganda si model number 2. Mas mataas yung adjusted R squared. Akaiki din guys, mas maganda si mali ito, no? So this is wrong. Okay, in terms of akaiki, mas maganda si model number 3. Bakit? Kasi mas mababa yung akaiki niya. Kung sino mas mababa guys, yun ang mas maganda. And then standard error guys, consistent yan with R squared, mas maganda si model number 2. So, ano yung ano yung decision natin? Well, we have to conduct ANOVA again. So, i-repeat natin yung process dito. So, ganun din guys, yung ginawa natin kanina, gagawin natin dito. And it turns out guys, isi-shortcut ko na, your F-stat is 1.77, p-value is 0.18. So, again, since p-value is greater than 0.05, hindi natin marireject yung null hypothesis natin na, okay, ano na ba yung tinanggal natin dito? Ang tinanggal natin is, what was removed? Number of dependents, no? So that's B7. Sorry, B7 to. So B7, ano? So tinanggal natin si B7. So sabi natin, okay siya natanggalin kasi si B7 statistically equal to 0 siya. So pag 0 si B7, ibig sabihin wala yung mako-contribute dun sa pag-explain kay hourly wage. So why include B7? Sabi nga natin, di ba? We are we would like to choose a parsimonious model. Pag sinabing parsimonious model, as much as possible, mas konti yung yung independent variables natin. Okay? So the restricted model, model 3, is better than model 2. Bakit? Kasi, again, hindi natin ma-reject yung null hypothesis na to. Okay? If this was less than 0.05, then i-reject natin yung null hypothesis na to. So we will conclude that B7 is not equal to 0. So kung i-reject natin yun, so dapat kasama si B7 sa model natin. That's what this is saying. Okay, so again, ano living variable dito, guys? Ang leaving variable natin dito is experience. No? So sa model number 3, ang tatanggalin natin experience to go to the next model, which is model number 4 now. Okay, so makita nyo yung stepwise regression natin. Ano? Stepwise backward regression. Okay, so ito na yung regression output natin. Okay, so in terms of akaike, guys, mali ito. So in terms of adjusted R squared, mas maganda si si model number dapat model number 4. Sorry guys ha. Paki-correct na lang model number 4 versus model number 3. So what we're comparing now guys is model number 4 and model number 3, no? Yung dalawa na yun ang kino-compare natin. Okay. So si model number 4, 5 na lang yung nila. This should be 4 na lang. 4 na lang yung variable siya guys, no? 1, 2, 3, 4. So education, tenure, female, at saka si married. Nagtanggal na tayo ng 3. In terms of adjusted R squared, mas maganda si model number 3. Okay, but we will not conclude from there, no? AIC, mas maganda si 114 point, tama ba ito? 114.32. 114.32. 1144.32. Tapos dito sa model number 1143. Okay, so okay, here it turns out guys na mas maganda si, tama ito, mas maganda si model number 3 in terms of akaiki. But sabi natin guys, kailangan i-test natin statistically. So ano ba yung tinagal natin? Yung beta 2 experience. Okay? So again, we did the same guys, nag-analysis of variance tayo. And it turns out that f-stat p-value 0.12. Our null hypothesis is that B2 is equal to 0. Si B2 guys, yung experience, yun ang tinagal natin. Diba? So it turns out that this hypothesis guys, we failed to reject it. Tama nga na B2 is equal to 0. We failed to reject it. This means guys that B2, should be B2, sorry. B2 does not contribute to explaining our dependent variable R wage. Hence, the restricted model 4 is better than model 3. Okay. Looking at our model number 4 guys. Okay, so tingnan natin dito. So lahat to guys, lahat to significant na. Okay? So there's no more independent variable to remove. Wala na. Nag-ano na siya, naging significant na siya, no? Lahat significant. So this will be our final model. Okay? So ang kasama si education, si tenure, si female at saka si married. Okay? So interpret natin to. Okay, anong ibig sabihin itong education? 0.529. Ibig sabihin, for every 1 year increase in education, there's a corresponding $0.529 increase in hourly wage. Ceteris paribus. So let me write that. For every 1 year increase in education, there's a corresponding .529 or point 5.3 na lang 5.3 increase in hourly wage. Ceteris paribus. Okay, that's our conclusion. Okay, for every 1 year increase in education, there's a corresponding $0.53 increase in hourly wage, ceteris paribus. Ibig sabihin ng ceteris paribus, guys, si education lang ang ipapa-increase natin ng 1. Yung tenure, female and married, hindi sila mag-i-increase. No? So that's what that means. Para makita natin marginal effect nito. Kasi kung hindi mag-i-increase to, so zero increase, zero increase, zero increase, ang makikita lang natin yung effect ni education. Okay, next, how about si tenure? Okay, so si tenure, guys, for every 1 year increase in tenure, si tenure kasi 1 yearly din, no? There's a corresponding, ano effect niya? 0.15154. Increase din, no? Increase in hourly wage. Increase din siya kasi positive siya. Okay? Then, ito si female. How do we interpret this? On the average, female workers or employees tend to get dollars $1.71 less than their male counterparts. Ceteris paribus. So this is telling us that si female, guys, kaya sabi ko dati, pag i-interpret natin tong factors, guys, kaya importanteng alam natin kung paano gawin, no? Yung factors, guys, pag i-interpret natin yan, okay? Always in relation to your base or reference factor. Ang reference factor natin si male. So si female daw, negative 1.7, it means less, no? Negative kasi compared to their male counterparts. Tapos ganun din si si married, guys. Si married pa, no? On the average, married employees tend to get 0.685, no? $0.685 kulang to hourly wage. So this should be more than their single counterparts. Okay? So gawin natin hourly wage. Okay. So on the average now, si married employees tend to get $0.685 hourly wage more than their single counterparts. Kasi positive to. And remember, guys, yung base natin dito is single. Okay? So this is your final model, guys. Yan. Ito na yon, no? And tingnan nyo, guys, kung tumigil na tayo dun sa unang-una, di ba, nag-model tayo, model number 1. Ito yung una. Tapos, di ba, ang natira na lang dito si education, si tenure, at saka si female. Okay? Tatlo lang, no? Tatlo. We would have removed the 4. So, mali yun, no? Kasi stepwise regression dictates that we have to do it step by step. So, nag-stepwise backward tayo dito. Take note, si married, guys, it was insignificant here. Pero nag-stepwise regression tayo, naging significant na siya dito. Significant na siya dito si married. So, pumasok na siya sa model natin. So, imagine kung yung first step pa lang, nag-stop na tayo, tapos tinanggal lang natin lahat ng mga insignificant, then mamamali tayo, guys, no? Kasi dapat magsi-stepwise tayo. Now, there in some instances, pareho rin yung makukuha, no? Lahat nagiging insignificant. Yung mga insignificant sa first step. But that we have to validate, no? Okay, lastly guys, ito. If you may guys, paki-copy. Pakita ko lang kung paano rin nanto, no? Let's copy this yung ganito na lang. I-ano nyo to, i-copy nyo. Copy nyo lang yung last worksheet na yan. Tapos I'll just illustrate to you how this is done. Clear all ko lang to. Okay. So ito yung data natin, di ba? Yung mga factors, na-convert na natin into dummy variables. Now, ito, minanwal natin to di ba? Inisa-isa natin yan. Tinetest natin yung nag-Anova tayo each step of the way. No? Each step of the way nag-Anova tayo. Okay, but with xreal stat, which you can do in add-ins lang sa Excel, we can do this with just one step, no? Okay, so Control M to get our xreal stat, then regression. Okay. Then yung x natin is, so lahat na to, no, parang ito yung first step, no? Yung 7 variables natin, tapos ang ano natin, ang independent, si hourly wage. Nangyari dito. Sorry na. Kumalaw siya. Okay. Then, column headings include, tapos ito guys, so stepwise. Tapos, pwede natin i-click to lahat, no? Yung regression analysis, Cook's, Durbin-Watson normality. Okay, then, so lagay natin sa S1. Okay, sa S1 yung output, sa pinakataas. Tapos, okay. Alright. So, ito yung output ni, ni xreal stat, no? So nag-stepwise siya, and ang lumalabas dito, education, tenure, female, married. Do we have the same values as our final model here? I-copy ko to, ha. Copy ko to. Control C. I'll paste the values. Okay, if you take a look guys, parehong-pareho siya, no? Exactly the same. Exactly the same guys yung output natin dito sa stepwise ni xreal stat. Pero ang ginamit na model guys ni xreal stat is what we call forward regression, no? Okay? Ano yung forward regression? Forward regression naman guys, ang ginagawa ng forward regression, magpapasok muna ng one variable at a time. Okay? One variable at a time. Tapos, kung final model na yun, tapos na. So ito, makikita natin dito. First step, pinasok niya si, this is variable 1 hanggang variable 7. So sa first step, wala pang 1A, wala pang mga variables, no? So first step, pinasok niya si 1. Tapos second step, pinasok niya si 3, no? Tapos third step, pinasok niya si 5. Tapos last step, pinasok niya si 6. Okay? So ito na yung 1, 3, 5, 6. Ito na yung education, di ba? Ayan, no? Pinasok niya si 1, education. Tapos si tenure. Tapos si si 5, which is si female kasama. And then si 6, which is married. Okay, so si 7, si 2, si 3 are not part of the model. So si experience hindi kasama. Si 4, si non-white hindi rin kasama. Tsaka si number of dependents hindi siya kasama. So this is the same as the final output, no? Okay? Right. So when you finish the model, guys, hindi ba dapat tapos yan, no? May karugtong pa yan. Okay, so may I invite you now to open the next file, yung sa R naman. Kindly open your R file, guys, yung shinare ko na OLS Wage Interact class January 29. So paki-check, guys, kung if you open that file, anong R markdown nakikita nyo? Ito ba? Kita ba natin to? Okay. Do you have it, guys? Paki-chat na lang kung pwede. So kindly open the R file, R markdown file. Paki-check lang, guys, kung nasa tab nyo dito yung OLSRR Wage Interact class January 29. Tapos paki-download din yung Excel file, yung Wage Interact, yun ang gagamitin natin dito. Guys, paki-chat nga kung ito yung tab na nakikita nyo sa R markdown. Pa-feedback please kung ito. Ay, sorry. Sorry. Okay. Yan. Kita nyo na? So yung R markdown na file na sinend ko, guys, paki-check if you're getting this tab, stepwise regression, OLSRR weighted wage interact class January 29.
Yes, sir.
Okay, thank you. Okay, I hope you have this, no? Tapos kailangan, guys, paki-download na rin yung Excel file, yung wage interact, which I sent din sa sa Canvas kasi yun ang gagamitin natin. Okay, paki-import na siya, no? Paki-import siya sa R. So in-import ko siya, guys. And then paki-run na nga pala yung mga packages na kailangan natin. OLSRR. This is for stepwise regression, no? Okay? So yung ginawa natin kanina sa Excel na inisa-isa natin, guys, na ginawa din natin sa XRealStat na add in na stepwise, kayang-kaya din gawin ni Arion, no? So I'm going to wait for you to be able to view Okay, ano guys, import yung wage interact. Import siya tapos i-view natin dito sa ano natin sa R. Tapos muna ako